Here we're going to look at the sum and difference identities and the cofunction identities. First things first, sometimes we don't know about certain angles, but we could compose of it a different way, and we do know things about it. I'm going to jump down to example 2 first, and then we'll come back up to example 1. Without a calculator, I don't know what the cosine of 75 degrees is. Okay, the unit circle that we have learned has 30-degree increments on it and 45-degree increments on it. So 30, 60, 90, right? 45, 90, 135, so on and so forth. So because I don't know cosine of 75, this problem is a challenge. However, if I rewrite this as, if my pencil works, the cosine of, and instead of 75, excuse me a second, excuse me. If I instead write this as the cosine of, and I say 30 degrees plus 45 degrees, then I can use this identity right here to find the values because I know stuff about 30 degrees and 45 degrees. Okay, now here's an interesting thing about the cosine sum and difference formula. It is, and it's like this on the formula sheet if you get it from me, okay? So we have two angles. In this case, U was the 30 degrees, V is the 45 degrees, and here there's a plus or a minus. Now, basically all I'm saying here is that this formula works for both if you use a plus or if you use a minus, okay? Here's what I mean by that. This formula is using a plus. That is the entry on the top here, okay? Because that is the entry on the top here, when using this formula, you are going to use the entry on the top. So you're going to use that minus sign, okay? So if you had generated an equivalence with a minus sign, you would be using the entry on the bottom. And if you use the entry on the bottom for the minus sign, you will use the plus sign here because that is the entry on the bottom, okay? So that's how we're going to use these formulas. So that means I can use that identity to say, well, that is equal to the cosine of 30 degrees times the cosine of 45 degrees. And now I'm using the one on the top, so then it's going to be a minus sine of 30 degrees, sine of 45 degrees. Now, I know information about sine and cosine and the 30 degrees and the 45 degrees because that's on my unit circle, okay? So thinking of my unit circle, and if you don't have one handy, you generate one on the fly, right? Quadrant 1 of your unit circle, 1, 2, 3, 1, 2, 3, they're all rooted and they're all over a 2. So cosine, the cosine of 30 degrees is root 3 over 2. The cosine of 45 degrees is root 2 over 2 minus the sine of 30 degrees is 1/2. The sine of 45 degrees is root 2 over 2. So to wrap it up, my final answer will be root 6 minus root 2. And since both of them are over 4, I can write this whole thing over 4, like so. Okay, or you can write each one of them over 4, okay? Now let's go up to the previous one. The previous one, they're giving us the angles in radian, okay? And they're having us do the cosine of, this would be U minus V if you're looking at your unit circle. Excuse me, if you're looking at your formula sheet, okay? Which has this on it, right? So this will equal cosine 5/4 pi cosine pi over 6. Now it has a minus sign, which is the operation on the bottom. So I'm going to use the operation on the bottom, plus sine 5/4 pi sine pi over 6, okay? Now, thinking of my unit circle, 5/4 pi is down here, okay? And pi over 6 is right here. So cosine of 5/4 pi is a negative root 2 over 2. Cosine of pi over 6 is root 3 over 2. Then a plus sign. Sine of 5/4 pi is negative root 2 over 2. Sine of pi over 6 is 1/2. So in the end, this produces a negative root 6 over 4 minus root 2 over 4. And since both of them are over 4, I can write it like so. Okay. All right, let's keep moving here. Now we have some more to practice. These have signs in them. So since this is a sine of 45 degrees minus 30 degrees, so basically it's asking, what's the sine of 15 degrees? Well, that's not on our unit circle. So we can do the 45 degrees minus 30 degrees instead and find this value. Okay, so I'm going to be using, I'm just going to zoom out here a little bit. I'm going to be using this top formula right here. Okay, and since I have a minus sign, which is the operation on the bottom, I will be using a minus sign, which is the operation on the bottom. Okay, so sine, then cosine. Maybe I'll keep it zoomed out for a little bit. It'll be sine 45 degrees, cosine 30 degrees, operation on the bottom, so minus cosine first angle, sine second angle. Okay, now we'll focus right here. We know that 45 degrees is here, 30 degrees is here. So root 2 over 2, root 3 over 2, minus cosine root 2 over 2, sine 1/2. So this will equal root 6 over 4 minus root 2 over 4. Okay, we have another one here. This, coincidentally, okay, this is going to be sine of 15 degrees. I know we already know the answer to that, but the point of it isn't that. The point of it is, if you saw you could do a 45 minus a 30, great. If you see 135 minus 120, also great. We should get the same answer regardless. Or maybe it'll look different, right? However, it has the same equivalent, right? So let's use the formula again. This time it's going to be sine 135 cosine second angle 120 minus cosine of first angle sine of second angle. Okay, so 135 degrees is right here, so that's a positive root 2 over 2. Cosine of 120, well, 120 is right there, so that'll be a negative 1/2 minus cosine of 135 is a negative root 2 over 2. Sine of 120 is a negative root, no, it's not, it's positive, it's up, root 3 over 2. And in the end, we get a negative root 2 over 4. This will turn to a plus root 6 over 4. Since they're both over 4, we can write it like that. And there's that. And now we can clearly see that these are equivalent. Okay? All right. When we learned about inverse functions, we learned that an inverse function will take in a ratio and come out with an angle. So this is basically saying sine of an angle plus, and then the same thing happens here. Arc sine takes in a ratio, outputs an angle. And I think I'll do this. This inverse would output, let's say, angle V. This inverse will output angle, let's say, W. So we have these angles, right? And we need to find this value. The cool part is we don't actually have to know the angles to answer this, okay? I can draw a picture that goes with this inverse. So we learned that, I'm going to take this one and bring it right over here. Inverse cosine will return in quadrants 1 or quadrant 2. Since it's positive, it's going to return in quadrant 1. Here, maybe you recognize it, maybe you don't, and it's okay if you don't. Cosine is adjacent over hypotenuse. Well, Pythagorean theorem puts a root 3 right here, okay? So this is angle V. Yes, if you recognize it as a pi over 3, that's fine. You just don't have to recognize it, okay? Now, let's draw angle W. Inverse sine returns angles in quadrant 1 or quadrant 4. It's a positive ratio, so we're going to put it in quadrant 1. Opposite over hypotenuse. Pythagorean theorem will give us a adjacent leg of 4. This is angle W, okay? Now, we know we have an identity that says this sine of U plus V is equal to, I'm going to just scroll up to it for a second, U plus V. So it's same function here that or identity here that we're going to use. If you have a plus sign, you will use the plus sign, okay? So it's sine first, cosine second, and then cosine first, sine second, okay? So it will be sine V cosine W. Now, I used V and W. Could I have used U and V? Sure. How about alpha and beta? Yes. X and Y? Sure. They're just variables that represent the angle. All right, and then plus, and then cosine of first, sine of the second. Okay, and now looking at my two pictures of the V and the W angle, sine of V, root 3 over 2, cosine of W, 4 over 5, plus cosine of V, 1/2, sine of W, 3/5. So what do we have here? We have 4 root 3 over 10 plus 3 over 10. You can leave it like this, or you can write it all over 10. Either way, same answer, okay? So you don't have to actually know those answers, or excuse me, those angles. You just have to be able to draw a picture of each angle and label the sides. So that's really key for those, okay? And yeah, and you could grab your calculator. Here it says check your answers with your calculator. Let's see if we can do that quick. Do I have a calculator handy? Let's grab a calculator. This one will be fine. Okay, what we had was root, It's in blue right here. We had the square roots of, I think it was was it a 3 or a 4? It was a 3. 3. And I actually might go in front here and write it like this. So 4 times the square root of 3, then plus 3. It's that number over 10, right? So that's the answer as a decimal. Now, remember, you could, let's see, we're going to go, the original problem was the sine of inverse cosine. The fraction was 1/2. Close it. Let's close the cosine. Plus, the next one was an inverse sine. The ratio was 3/5. Close it. Close it. Okay, one thing to be careful about is every time you've opened a parenthesis, close it. Like I put this 1 in front of the inverse cosine. I didn't really need it. And look, we got the same answer, so I feel really good about our representation of it. All right, let's go back. All right. Same formulas again, but this time we're going to do tangent. So this is our u, this is our v. We're going to follow this formula. Is a 1. For pi over 6, the tangent, so that's going to equal 1/2 divided by root 3 over 2. In other words, 1 over root 3, and yes, you can rationalize it. Okay, so I'm going to come back over here. So this is going to be how to simplify this many different ways. Here's how I'm going to do it, okay? The rule is, one rule, like one of the methods is I can multiply the top and the bottom by anything I want. And I'm a little bit sneaky, so I'm going to choose to multiply it by square root of 3. Square root of 3. Now, the top fraction of the big fraction bar, which is right here, top is getting multiplied by root 3, bottom is getting multiplied by root 3. That is a legal mathematical move. When I distribute here, the top will turn in, the first one will turn into root 3 over 3. The second piece here will turn into a root 3. Root 3 over 3 is a 1. 1 times root 3 is root 3. Now the bottom of my fraction is going to turn into a root 3 minus root 3 over 3. Don't cancel stuff. That's not how math works. Once their addition or subtraction is involved, you can't just go cancel things. That's as good as it gets without going to decimals or rationalizing the denominator even more. I'm not going to do that. That's not what this section is about. Okay. Now, could I grab my calculator, punch this in, and see what I get? Yes, you'll get a decimal. Could I then grab my calculator, punch in this to see what I get? Yes, and you would find that they match. Okay. Next, remember the problem we had a bit ago where we didn't have to actually know the angles? We just had to know what the sides of the triangles were for those angles, okay? That's the same with these. They're not telling us what alpha is. They're just telling us that here, they're telling us alpha is in quadrant 1, between 0 and 2 pi. Here, they're telling us that beta is between pi and 3 pi over 2. So it's down in quadrant 3. Okay? I'm going to draw a picture of both alpha and beta. So alpha is in quadrant 1. Okay? Next, they're telling us that the sine of alpha is 3 over 5. So that's the opposite over the hypotenuse. Well, Pythagorean theorem will give me a 4 for that adjacent leg because this is a right triangle. That's alpha. Now I'm going to draw beta. -5 here, 13 here, and this is beta. Okay? Now, Pythagorean theorem, let's see, 169 minus 25 will give me an adjacent leg of 12. Now, I have to be careful, though. Is it 12 or is it -12? Well, if it's down in quadrant 3, then that y value is a negative. Okay? All right, so I have a picture of alpha, I have a picture of beta. Now let's get to answering these questions. Sine of alpha plus beta. Well, again, we're going to use that identity. I did drop it again right here. Let's see. Sine first, cosine second. Sine first, cosine second, plus sine. Cosine first, sine second. Okay. Now, look at your pictures. Sine of alpha. Well, sometimes it erases when I don't want it to. Sine of alpha is 3/5. Cosine beta is a negative 5/13. I know it can simplify it. I'm not going to, though. There's a reason here. Cosine alpha, 4/5. Sine beta is a negative 12/13. Both of them are over 65. Okay, so I get a negative 15 over 65 plus a negative 48 over 65. So I can rewrite it like so and clean it up. 40, 50, 60, negative 63 over 65 will be the answer there. Okay, let's go to the next one. There's 4 here. Let's see if I can squeeze it in a little bit smaller maybe. Cosine. Let's just refresh your memory here. Cosine is cosine first, cosine second, opposite sign, sine, sine. Cosine, cosine, sine, sine. So this one is going to be cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, looking at my picture, cosine alpha is 4/5. Cosine beta is negative 5/13. Minus sine alpha, 3/5. Sine beta, negative 12/13. Negative 20 plus 36, and both of those are over 65. We will get a positive 16/65, like so. Okay, let's go to the next one. Tangent alpha, tangent beta. The top, I'm just going to zoom out to refresh our memory again here. Right here, it is tangent first plus or minus, whichever, tangent second. So this one will be tangent alpha plus tangent beta over 1, and then it's opposite sign, minus, and then tangent alpha times tangent beta. All right, I'm looking at my pictures. Should have given myself more room here. Tangent alpha is 3/4 plus tangent beta. Negative over a negative will be positive. 12/5 over 1 minus tangent alpha times tangent beta. All right, some cleanup here. Couple options. I see, if you remember how I did in the previous up here, I multiplied everything by root 3 because, and the choice there was because there was a root 3 in the denominators. I have a 4 in the denominator and a 5 in the denominator this time. So I'm actually going to multiply everything by a 20 on top and a 20 on the bottom. Okay, here is why. When I'm going to work vertically. When I distribute here, I will get 60/4, or in other words, I'll get a 15/1 plus. When I distribute here, I will get 240/5 or 48. Let's go to the denominator. When I distribute here, I will get 20. When I distribute here, I will have a factor of 20 on top and a factor of 20 on the bottom, simplifying to just 36. So in the end, we will get a 63 on top and a negative 16 on the bottom. Okay? All right, I got one more. It's tangent alpha minus beta. The process is going to be very simple and similar to what we did before, where it was, don't lock up on me, tangent alpha minus tangent beta over 1 plus the product of tangent alpha tangent beta. All right, now time for us to look at the pictures again. See, we didn't need to know the angle for any of these. We just needed to know what it looks like, what quadrant it's in, and whether the x's and the y's have positive or negatives in front of them. So tangent is 3/4 minus 12 over 5, they're both negative, over 1 plus 3/4 times 12 over 5. Now I'm going to do the same thing as I did a little bit ago and multiply top and bottom by a 20. I will get 15 minus 48 over 20 plus 36. 33 on negative 33 on the top and a 56 on the bottom. Woof. All right. Point is, we don't have to have the angles exactly. We just have to be able to draw them to execute those types of problems. All right. Number 7 here, we're just going to alleviate the stress a little bit. Write tangent of pi over 9 in terms of its cofunction. Now, no calculator. I don't need to know what this is equivalent to in degrees. I don't need to know any of that. What I need to know is, what does it mean to be a cofunction? Well, cofunctions, okay, are the function where if you had the complementary angle, you would get the same ratio answer. What? Let's go over here. When we learned this, when we were learning these identities, tangent and cotangent were cofunctions of each other as long as, and they were equivalent then, as long as these angles in here were complements, which means they add up to 90 degrees. Or in radians, they add up to pi over 2. So in other words, for this problem, it says tangent of pi over 9. So we're going to be looking here at the bottom one. If this is pi over 9, then the cotangent is going to be, or we're going to write the cotangent, but the angle here is going to be pi over 2 minus pi over 9. So that'll be the complement angle. So the complement is you take your pi over 2, you get rid of that angle, and you see what's left, right? We'll have to get a common denominator, be a 19. So let's see. Excuse me, I didn't mean 19, I meant 18. This will be 9 over 18. This will be a 2 over 18. We still need the pi. In other words, we're going to get 7 over 18. So this is going to be cotangent (7 over 18 pi), cofunction of complementary angles. Okay? All right, now they're asking us to verify an identity, which is basically just saying, hey, prove that the left side and the right side are equal. I'm going to use my identities. We have them listed here again. Sine alpha plus beta. I didn't give us a lot of room. Hopefully that means there's not a lot of work, right? Sine alpha plus beta. We're going to do this identity first. sine alpha cosine beta plus cosine alpha sine beta. Okay, that was just this first one. Next one is plus, and then this, which is going to be this again, except for you'll be looking at a minus there, which means you'll be looking at a minus there. Okay, sine alpha cosine beta minus cosine beta sine alpha. And we clean house. Do I need the parentheses if it's just a plus sign to distribute? No. Okay. Well, if you take a look at this, cosine beta times a sine alpha, that's the same as this. This one's got a positive in front. This one's got a minus in front. They're gone. What's left? A positive. Ooh, do I have a typo? I might have a typo. Oh, I think I did. I do have a typo. This right here. Let's go back here. This should be first. This should be second. Cosine alpha sine beta. There you go. Now, that doesn't negate with that one. Cosine alpha sine beta. Cosine alpha. That negates with that one. Okay, now it makes sense. Now it's coming out the way we need it to, right? I have a sine alpha cosine beta, sine alpha cosine beta. So in other words, I have two of them. 2 sine alpha cosine betas, and that equals what we intended it to. And as you just saw, instructors make mistakes too. And we got to go back and rethink what we did wrong. All right. Another verify. I feel like you kind of get the handle on that. I'll do it quick, but then I'd like to get to these two. These are definitely, the last two here are the challenge problems. This one, number 9, not so much, but 10 and 11 certainly are. Sine alpha minus beta. Again, I'm going to use the identity, and we're going to have from up here, sine alpha cosine beta minus cosine alpha sine beta. That is the top, and all of this is over cosine alpha cosine beta. Okay, well, I'm going to write each one of them over that denominator individually. So here's what I mean by that. This and this individually has this denominator, because then those cancel. Same thing here. Those cancel. Well, what's left? Sine alpha over cosine alpha. And that's tangent alpha. And then a minus sign. Sine beta over cosine beta. And we just proved what we were trying to prove. All right. Tricky problems. Okay, take a look at this. They want us to use the picture and what we can see on the picture to show this. What? Okay. A couple different approaches that I have here is I have two different thoughts going through my mind. When you look at the unit circle and you look at the rise over run when you're looking at any angle, isn't that rise over run the y value over the x value? And it doesn't even have to be the unit circle. It can be larger than it by a factor of whatever factor it is. Yeah? The tangent is the opposite, which is the rise, over the adjacent, which is the run. So the tangent of theta sub 1 is the slope of, I think there's a typo here, slope of line 2. Yeah, I think there's a typo error. Let's do the problem a different way. That maybe I can avoid it. They want to know the tangent of angle theta. The tangent of angle theta. Well, that's kind of difficult when it's not laid out on the positive x-axis like we're used to seeing, right? So then how do we find it? Yeah? Well, let's rewrite the angle theta. Geometry, taking you back to high school geometry, this angle theta right here is the same as this angle theta right there, okay? Now, all of the angles inside of a triangle add up to 180 degrees, or in other words, pi, right? So if the sum of all the angles is pi, let's write down all of these angles. So we're going to have to go in deep here. Obviously, theta sub 1 plus, now let's talk about this inside one. It's not red, the outside. We want to know what's the inside part of it right here. So that inside part is going to be 180 degrees, or in other words, pi, minus that outside one, theta sub 2. Okay, that's the red. And then this one right here is the one that they've just called theta. Now we know that all of these added together is equal to pi. Okay? Now, here's an interesting thing with this. I don't need the parentheses around the red angle because there's nothing to distribute. It's a plus sign, not a minus sign. If I subtract pi on both sides, they're gone. Okay? I'm going to add pi over 2 to this side. And I'm going to subtract, excuse me, I didn't mean pi over 2, I meant theta sub 2. And I'm going to subtract theta sub 1. The only thing left on the right side is theta, and on the left side, it's theta sub 2 minus theta sub 1. That means that the tangent of theta is equal to the tangent of theta sub 2 minus theta sub 1. And I know that I can use my tangent sum and difference formulas to rewrite this. And it would look like tangent theta sub 2 minus tangent theta sub 1 over 1 plus tangent theta sub 2 times tangent theta sub 1. Okay? Now, they mislabeled, I think they mislabeled these two lines, okay? Because for theta sub 1, we're talking about the blue line, which is line 1. So that's M sub 1. The red, it corresponds with theta sub 2. Tangent theta sub 2 is equal to M2. Does that make sense? So they right here, this is a typo. or rather the way they have them labeled on the picture is a typo. Okay, so what does that mean for us? That means for us, this is m sub 2 minus m sub 1 over 1 plus m2, m1. And that is what we were trying to prove, given that information. Okay? All right, last problem for this particular section, and that is here we have a climbing wall, and we have a guy wire on it, holding it steady. There is a guy wire R, which is anchored 47 feet up, 50 feet out. The guy wire S is anchored 40 feet up and 50 feet out. If the wires are attached to the ground 50 feet out, find the angle alpha between the wires. So it's asking for the little one, okay? All right, well, here's what I know. There's multiple ways to approach it. It's looking like it's calling both of these collectively beta, okay? Now, if alpha is this little one, then the inside of this one here is beta minus alpha. Okay? So here's what I know. I know that the tangent of beta minus alpha is equal to 40 over 50. I can say 40 over 50, or I could do 4 over 5, right, to simplify it. Okay. Another fact that I know is that tangent of beta is equal to 47 over 50. Okay. And I don't know alpha. All right, so let's use what we know here. Let's use the sum and difference formula for tangent here. So, and I actually think I'll go with the 4 over 5. What is the formula? How can we rewrite this? Well, tangent beta minus tangent alpha over 1 plus tangent beta times tangent alpha. I don't know tangent alpha, okay? But I do know tangent beta, so I'll fill those in. 47 over 50 minus tangent alpha over 1 plus 47 over 50 tangent alpha. Just like before, I don't have to do it to both sides of the equation, okay? I'm going to do it to the top and the bottom. Okay, that's the rule. Either on both sides of the equation or top and bottom, okay? So we have 4 over 5 is equal to 47 minus 50 tangent alpha over 50 plus 47 tangent alpha. Okay? Now, I'm going to cross multiply this. Or rather, take this denominator and multiply it on both sides. What that will give me is 4/5 of 50 plus 47 tangent alpha equals 47 minus 50 tangent alpha. Okay, here's my game plan. My game plan is, if I can solve this and solve it for tangent alpha, and it's equal to some number, right? Then I can do an inverse tangent on both sides take in that ratio, and find out what alpha is as my angle. So I need to first, with the left side stuff here, isolate tangent alpha. And yes, I just put them on both sides of the equation, but that's the only way to get it out of the denominator when you have pluses or minuses going on like we do. Okay, I'm going to distribute my 4/5. This will give me a 40. Now that'll simplify to 10, right? And then plus whatever 4 times 47 over 5 tangent alpha is. And this equals okay. Let's subtract 40 on each side and add 50 tangent alpha on both sides, which means we have 50 tangent alphas plus, grabbing my calculator, 40 times 47, excuse me, I don't mean that, 4 times 47 divided by 50. All right, this side is just a 7. To get some numbers here, we'll have an 87.6 tangent alpha equals 7, which means divide by 87.6 gives us 0.079908678. Okay, so if I have that, this is the ratio. Doesn't look like a very big angle. Well, but the picture showed it kind of small, so it shouldn't be a very big angle, right? 0.079908678. All right. Inverse tangent of that, grab your calculator, inverse tangent, we will get a very small positive angle. If you are in degree mode, you will get 4.5687 degrees. If you're in radian mode, you will get 0.08 radians. That's very small. I'm going to keep it in degrees, I think. So there is angle alpha, which is the angle between the two guide wires that they were asking for. And it should be small. All right.